In this video, we're going to talk about how we determine the limits of integration on a definite integral. There's our topic for today. Here's our situation. P prime of t represents the rate of change in the population of fireflies, where P is measured in thousands of fireflies and t is measured in months since the beginning of the year. We're asked to write a definite integral to determine the change in the firefly population from t equals 6 months to t equals 9 months. Well, we know to find the change in the population, we're going to have to integrate our rate of change, p prime of t dt. That's no surprise, and in this case, the limits of integration are also really easy. We're going from t equals 6 months to t equals 9 months. So our limits of integration go from 6 to 9. That one's almost too easy to bother with. Let's try something that's a little bit more challenging. This time, we need to write a definite integral to determine the change in the firefly population during the third month of the year. So a lot of people make mistakes with this one because they might go from 0 to 3 or they might go from 3 to 4. Honestly, I count this on my fingers. If I'm going for the third month of the year, I know that January is the first month from 0 to 1. February is the second month and it goes from 1 to 2. March is the third month and it goes from 2 to 3. So the correct limits of integration are from 2 to 3. Let's try this next one. Write a definite integral to determine the change in the firefly population from the beginning of April to the end of June. Again, this one is pretty tricky. When they say the beginning of April, a lot of people think, well, April is the fourth month, so I should begin my definite integral at 4. That would be incorrect though, because after 4 months, you're at the end of April. The trick is, this starts at 3, and then you have April, May, and June. And so you have a total of 3 months, starting from 3, add another 3 months, and you're going to be at 6. And so this definite integral is going to sum up 3 months worth of firefly population. Okay, let's see. Here's a little twist. At the end of May, there were 16,000 fireflies in the area. Write an integral expression to determine the number of fireflies at the end of August. So this is a problem where we have this initial population of 16,000 fireflies, and then we're going to add the change in the population going from May to August. So in other words, I'm starting with the population at the 5th month, and I'm going to be adding an integral from 5 to 8. P prime of t dt. Is there a way to check this? Yes, in fact there is. What I can do is if I integrate p prime, that'll put me at p of t, and then using the fundamental theorem of calculus, I'll have p of 5 plus p of 8 minus p of 5, and notice the p of 5's drop out, and I'm left with the population at the end of the 8th month. That's what I was looking for. And so this seems like a good approach. Okay, notice that these values here have to match the initial value, and so this is where I start from, and then I'm going to there. Here's another problem where we're given an initial value. Again, at the end of May, there are 16,000 fireflies in the area, and we want to write an integral expression to determine the number of fireflies at the end of February. Okay. So we again have an initial population at the 5th month, plus we're going to integrate. Now remember that these need to match, so I'll put a 5 there. And then I need to think about kind of counting backwards, I suppose. The end of May, so I need to go backwards through May, backwards through April, backwards through March, and then if I go backwards all the way through March, I've arrived at the end of February. So I need to go backwards 3 months. So 5 minus 3 puts me at 2. Again, I'd like to double check this because, I don't know, I'm just a little bit nervous about my answer here. So, remembering that if I integrate p prime, that puts me at p. And now, I'm going to evaluate using my fundamental theorem of calculus. I'll have p of 2 minus p of 5. Notice again that These P of 5's divide out, and I'm left with the population after 2 months. So let's see, 2 months, that would be January and February. So that's the end of February. It looks like I've done this correctly. Okay, I hope you've learned something about how to establish the limits of integration in an application problem involving definite integrals. Thanks for listening, and remember, as always, to enjoy calculus.